Now this third method is the one that's actually the least efficient, but it also turns out to be the one that you often were taught in high school. So it seems like many people just go for this method, and because of that I'll still show you how to do it, but really this is not the good way to do it. Well, this is about solving for y and setting things to equal to each other. So basic idea is that intersection is about set them equal to each other. That's how you're taught. So to use this idea, what you do is you have to solve each one for y. So x plus 4y equals to 48. And then when you subtract x, you get 4y equals to 48 minus x. Divide by 4. You get y equals to 16 minus 1/4 of x. And since this is rather getting boring, let me just do the same thing for the second equation. So if you have 3x plus 4y equals to 64, then when you subtract 3x to the other side, and then divide by 4, you get 64 divided by 4 is 16. Oh, sorry, this would be 12 here. And this would be 16 minus 3 over 4x. Now, this third method is actually the one that is the least efficient, but it also happens to be the one method that you were taught in high school. You were taught in high school that intersection is obtained by set them equal to each other, setting two sides equal. Okay, and then solve. Now, since so many students do it this way, although I really don't like this method and it's inefficient, I'll still show you how it's done. So first, you have to solve each of these equations for y. So you have x plus 4y equals to 48. Subtract x both sides, so you get 4y equals to 48 minus x. Divide by 4, and then 48 divided by 4 will be 12, and you get negative 1/4 x. Do the same for the other. 3x plus 4y equals to 64. Subtract 3x, and you get 4y equals to 64 minus 3x. And divide by 4, you get y equals to 16 minus 3/4 of x. And then you set them equal to each other. You get 12 minus 1/4 of x equals to 16 minus 3 over 4x. I guess you want to subtract 12 both sides. So you get negative 1/4 of x equals to 16 minus 12 is 4 minus 3 over 4x. And then you add 3/4 of x both sides so that these cancel. And 3/4 minus 1/4, fortunately they have the common denominator. We got lucky. So this would be 2 over 4, x equals to 4. And then multiply by 4 over 2 both sides. That's how you cancel things, right? So you get x equal to 16 divided by 2, which is 8. Once you get 8, just like the other methods, you have to plug it back into the equation. And then, well, you can plug in here. 8 times 1/4 is 2. 12 minus 2 will be 10. So you get y equals to 10. So the answer is x, y would be 8 and 10. Okay. You can do the same here. Let's try it. Let me do this quickly because it's basically the same thing. If you solve for y, you get 64 divided by 4 is 16. You get, oh, actually we did that already. And then the second one, if you solve for y, it's 31 minus 2x. And then set them equal to each other. So you get 16 minus 3 over 4x equals to 31 minus 2x. Now, there's one thing that's really efficient when you have fractions in an equation. You just multiply by that denominator so that it deletes everything. 4 times 16 is 64. 3 over 4 times 4 is just 3. 31 times 4 is 124. 4 times 2 is negative 8. And then if you move it here, move that there, you get 5x equals to 60. So then you get x equals to 12. and put that back into this equation here, so you get y equals to 7. So, I mean, it might seem easy for you because this was how you were taught, but actually this often gives you some really ugly fractions, and it's not the best way to do solving this system of equations.